So after last week talking about the distribution of data, measures of center, measures of spread, you should get the idea that in statistics, we care a lot about how data is distributed. Like what's the shape of the distribution? And a lot of distributions have this particular shape called the normal distribution, where there's a peak in the middle and it trails off to the two sides. When that is the case, there's a lot of tools that you can use, sort of mathematical tools that you can use to analyze the data. In particular, you can break it into percentiles. So we're going to take a look at this virus incubation example, but let me go back a couple of slides to this one, because this example we are thinking about the normal distribution and the 68, 95, 99.7% rule. If data is normally distributed, 68% of the data will fall within one standard deviation of the mean value. So that means if you take the mean value and you add one standard deviation or subtract one standard deviation, that will give you two endpoints. 68% of the data should fall in between those two endpoints. And then the same thing goes for 95%, that's two standard deviation range. 99.7%, that's a three standard deviation range. So basically, when you have a normal distribution, almost all of the data is going to fall within three standard deviations of that mean value. So for instance, a value of 4 standard deviations, that would be really unusual. So only 0.3% of all data will fall outside of this 3 standard deviation range. Now, so this rule is really important. Another important idea is that the normal distribution is entirely determined by two numbers, and the two numbers are the mean value and the standard deviation. Okay, so here we are, the virus incubation example. We have the mean given to us, it's 8 days, and the standard deviation is also given to us, that's 2 days. Those two numbers determine everything about the normal distribution. The 68, 95, 99.7 rule applies, and so we can say 68% is within that 2-day range of 8 days. So to answer question A, approximately 68% of infected people will show symptoms between what numbers? Well, the mean is 8. One standard deviation below would be 8 minus 2, so that would be a 6. One standard deviation above would be 8 plus 2, so that's going to be 10. So the one standard deviation range is from 6 to 10 days. Now, going to the 2 standard deviation or 3 standard deviation range, all you're doing is you're doubling or tripling this standard deviation number. So in this particular example, a standard deviation means 2 days, so 2 standard deviations means 4 days. So if you subtract or add 4, you get the range from 4 to 12. So our answers here would be 4 days and 12 days. And then 3 times 2 for a 3 standard deviation range is going to be 6. So 8 minus 6 gives me 2. 8 plus 6 gives me 14. So the 99.7% are going to be found between 2 days and 14 days. So looking at this one, part C, almost everybody who acquires this virus is going to show symptoms from the 2-day point to the 14-day point. So almost everybody falls in that range. You might have occasionally 0.3% of the time someone at like 1 day and someone at 15 days. Almost everybody's going to be between 2 and 14. 68% of people are going to be between 6 and 10. 95% of people are going to be between 4 and 12. So once you know the mean value and you know the standard deviation, you can segment the distribution into these percentile values and use it to think about what possible values there might be and how likely they are to occur. Values within 1 standard deviation are pretty common. 68% of the time you're going to be found in there. 95% of the time you're going to be found in here. And almost all the time you'll be found within this 3 standard deviation range.